What you have just witnessed is a reaction between pure sodium metal and water. Sodium metal is a very reactive metal. Because of its reactivity, sodium does not exist freely in nature. Sodium is, however, found combined with other elements to form compounds like rock salt, which is sodium chloride, trona, which is a double salt of sodium carbonate and sodium hydrogen carbonate. The chief ore of sodium is rock salt. Sodium is obtained from sodium chloride through electrolysis of fused molten sodium chloride. The down cell is a specialized cell used to separate sodium and chlorine. The down cell is a circular furnace made up of iron shell lined up with fire bricks. A lot of heat energy is required at the down cell. The fire bricks are used to maintain the high temperatures required. At the center of the down cell is the graphite anode. The anode is made up of graphite and not steel. Graphite is inert and thus does not react with the chlorine gas produced at the anode. If steel was used at the anode, it can easily react with the chlorine formed at the anode because of the high temperatures. The graphite anode is surrounded by an iron cathode. The cathode can also be made up of steel. The anode and cathode are separated by a cylindrical steel screen. This screen can also be made up of iron. The purpose of the steel screen is to prevent the recombining of sodium and chlorine once they have been separated. Sodium chloride has to be in molten state before electrolysis can take place. The melting point of sodium chloride is 800 degrees Celsius. It is actually very expensive to maintain such high temperatures. To lower the melting point of sodium chloride, calcium chloride is added. Calcium chloride lowers the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius. Alternatively, calcium fluoride can be used. During electrolysis, sodium ions migrate to the cathode, while chloride ions migrate to the anode. At the cathode, sodium ions gain electrons to form sodium atoms. Thus, sodium metal is formed at the cathode. Sodium metal being lighter than sodium chloride, it floats on sodium chloride. Sodium is tapped off at the top. At the anode, chloride ions lose electrons to form chlorine gas, which leaves the down cell through a pipe at the top. Chlorine gas is collected in a separate and safe chamber. Chlorine gas cannot be left to escape into the atmosphere given that the gas is very poisonous. It is worth noting that calcium chloride, which was added to lower the melting point of sodium chloride, also breaks into calcium and chloride ions. The calcium ions migrate to the cathode but are not preferentially discharged because of their lower concentration. That marks the end of the process of extracting sodium metal by the down cell.
To check whether you have understood everything, please answer the following questions. Explain why calcium chloride is added to sodium chloride in the down cell during electrolysis of fused sodium chloride. Explain why the anode is made up of graphite instead of steel. Once you have answered the questions, give your teacher to mark. That brings us to the end of this lesson.